Thank you. Well, before the slide projector is pressed into service, I would like to speak a little bit on Tom's behalf about the AM QRP situation. But basically, it was born in the winter when people seem to have a lot of time on their hands, and a number of us that go back way before my time remember what it was like to take simple parts, whatever you could get your hands on, and throw together a simple transmitter and see what you could do. But back then, I guess everybody, or a large portion of the amateur group, operated AM, and things were very crowded. Well, times have changed, and people have been rediscovering that they can work over great distances with low power. So I got back from a work trip and fired up this little rig that I had, which was a screen modulated, that is cathode follower, high fidelity, screen modulated, 6DQ6 crystal oscillator transmitter that made all of a whopping 2.5 watts out. And I amazed myself at what I could do with the thing on 160. I was talking back and forth from Syracuse, New York to Tom in Connecticut, night after night, many other stations that were hearing at Q5. But when you run low power, you're at the mercy of Mother Nature, being static or propagation. So sometimes it works very well, but at this particular point in time where the absorption levels are getting up higher and higher, it's time to think about better band conditions coming up in the fall and what you're going to do for a low power transmitter. But the thing about low power transmitters that sets them apart from higher power transmitters is that you can use many more different modulation schemes, i.e. Heising Class A modulation, which in a larger transmitter is very much a power hog. But with a low power transmitter, well, 6L6 modulator, 6V6 final. A very popular tube in the QRP transmitters is the 6AQ5. And then it's like, what do we make them out of? Well, you rummage around the hamfests and look around for some old carcass that nobody wants, like from an old TV set. Well, for instance, you can use an old vertical output transformer as a Heising reactor with a little bit of a step up with the additional secondary winding to achieve 100% modulation. Use the power supply. But then again, we have broken it down into two classes of QRP stations. The Class B stations are anything up to 10 watts RF output, and the Class A's 1 watt and under. Well, I decided to build a 1 watt unit, but more or less borrow a lot of more efficient power, shall we say, more efficient means of converting electrical power into RF. So I wound up with a 6AQ5 crystal oscillator, a 12AX7 and push-pull as a Class B modulator. It pulls all of a whopping 7 mils at idle and kicks to about 15 milliamps at full modulation. The 3-diode ultramodulation circuit to ensure that I don't overmodulate on negatives and therefore pull the frequency and cause the thing to FM. Well, let's go to the other end of the spectrum here to something of very high power. Well, what do we have here?
That's WA3YXN's QRP ring.
Oh, that's Dennis's. Well, that's just one fine example. It looks like we have a pair of T3s. What do we have there? Those are 6AV5s? Let's look at the back of that.
All 6AV5s.
Ah, fine business TV sweep tubes. There is a rule. Maximum plate dissipation, no more than 20 watts. So 6DQ6 and 6AV5s and things like that are considered the largest bottles that one can use. Well, it looks like, what do we have here? One is a final and one is a Heising modulator?
I think Dennis is here. Dennis.
Yeah. No, Class B. They're up in Class B modulator.
Class B. Triode connected.
Yes.
Very nice. Very nice. Ah, here we are. This is basically what the transmitter is an old RCA ampliphase that we gutted out and used the cabinetry and the control circuitry and primary wiring and converted it over more or less to a plate modulated transmitter. What you see is just myself talking with some of the other crew that are installing and working on things as to how we're going to do things out. We're all gathered around the modulation transformer. What you see in the foreground are the Heising capacitors, and behind the modulation transformers, the Heising reactor. And the three objects, the three pole pigs you see are the plate transformers. And then, of course, the back of the transmitter, the open part of the cabinet, is our AC power and distribution. So I'll move on to the next slide. Ah, yes, this is the AC distribution panel. It takes the 483 phase and brings it down to 243 phase, which operates all your blowers and filaments and lower level stages within the transmitter, as well as our 480 disconnect, our delta Y switch for high and low power, and that big box on the wall there that's enclosed is a combination circuit breaker and a plate contactor. So we'll move on to the next guy. All right, this is as things are coming together, a room which eventually will become a screen room. You see the mod iron and the plate iron being arranged, and the PVC plastic conduits being arranged for the wiring here. And here's the finished installation of the transmitter. The first cabinet from left to right is the RF. The second cabinet is our driver and low voltage power supply. The third cabinet is the modulator, and the fourth cabinet is the rectifier cabinet. Unfortunately, I don't have all the photographs of all the intricate details, but I can kind of explain and fill in the gaps as we go. But basically, the transmitter was going to be designed to cover from, say, 49 meter shortwave up to 19 meters. As it is, I had the driver working over that entire frequency range. I'll tell you, if I had the time, it would have showed up on 7290. All right, next picture, please. This is the inside view of the rectifier cabinet. Those plug-in stacks are just for the IPA and driver, or shall we say just the driver. The stacks on the right are the high voltage, which at full power was about 13.5 kV, and down the very bottom is a step-start high voltage contactor that allows the bank of oil condensers, which are sitting in the bottom that you really can't see, to come up to a charge without causing the utility to the utility's voltage regulators to palpitate a bit. All right, next shot, please. Well, this is our exciter cabinet. The transmitter was just basically built from pieces, parts borrowed here and there. Over on the right-hand side, you see a little plug-in module with a crystal that I think was a 7490 crystal. That module comes from a old Continental AM transmitter, 6AG7. Hidden behind it is an 807, which is a buffer, and in the little metal box is 4-65. And the metal box that the whole thing is built on is on hinges, so you can flip the whole thing up and get underneath. And those knobs are your various band switches and tuning controls. Next to it is the ever more popular 4CX5000, and the coil you see is for 19 meters, which attaches to a roller inductor on the side that you really can't see, and two with about 30 kilowatts of plate dissipation, and typically you run about an amp of grid current on it.
Wow.
And a couple of kilowatts of drive. And what you see up above with the bread slicer and the coil is the grid input circuit and the grid parasitic suppressor, that big long resistor. And then you see over on the right-hand side, those two ceramic capacitors. Those are the plate blockers. Those are two 450 puff 50 kilovolt vacuum caps. But you notice that there's another vacuum variable that's over on the right-hand side. That is the neutralization capacitor. And then you see all those different lengths of copper tubing with all that cluster of big resistors around it. Basically, the final amplifier was put together very quickly, and little did I realize at the time that the lead length between the final amplifier tube and the plate tuning capacitor, you could set up some pretty serious chances of parasitic oscillations. I use a piece of ceramic as nothing more than an air chimbley. And then on the side you can see the plate RF choke and the drive for the vacuum variables for tuning and loading. That's the tank coil, which is probably about that big around. You can see the tuning cap on the left, the component with those 0.01 20 kV oils to spare the life of the carbon resistors, and tacked across them on the back side. Each one actually are small disc ceramics. Goes in a negative feedback ladder and a broadcast transmitter and everybody was in question, how do we go from balanced to unbalanced? And I thought to myself, why not a half-wave coax balun? They happen to have a surplus of 4 1/8 inch. Actually, that worked better than their store-bought antenna tuner, which had problems handling 50 kilowatts, whereas the balun just did the job no problem at all. And this here is the antenna. It's about 300 and some odd feet per leg, 80-foot poles, very fine 3-wire rhombic. No tilt angle to it, so it's not quite optimized, but it does work nonetheless. And this next shot is Henry Yallar Mobile. You see the Johnson matchbox. You can't see the open wire line going over to the rhombic, but while I was there for 5 days doing the transmitter installation before we put the thing on the air, I was operating on 75, 9 o'clock at night, getting on 40 meters at around noon during lunch break, but it was a very busy work schedule. Got on 10 meters once, fired up and just sat there and went, "Hola, hola." And somebody in Spain came back and I couldn't understand a word that he said. And then at that time I shut down, and the next time any RF emanated was probably 12 hours later, maybe around 2 in the morning, when we came on a reduced power at 18 kilowatts on 7490. They were in such a rush to get on the air. Boy, it would have been fun to fire up on 7290. Well, now going to something completely different. A friend of mine out near Buffalo purchased a 20V from the shop under the condition that it get converted over for amateur service. And there we have, as it's referred to as the 20VX, still in the plastic wrapping at the shop. It's been multi-banded to cover from 160 through 40. There's a roller inductor up in there. As you can see from the front panel, very little has changed. Very little has changed. What we see, where there used to be a power control for like high and low power, Collins' idea of very wasteful, inefficient means